This is a review for standard 3.3 of stoichiometry. We're going to be reviewing limiting reactant and also percent yield. So the first question is, what is a limiting reactant? Limiting reactant just means it's the reactant that is going to run out first during the chemical reaction. So it's going to determine how much product you can make. For example, if you were making, let's say, cheese sandwiches and you had, 4 pieces of bread and 3 pieces of cheese. So we'll say we have here, these are breads. They're blue for some reason. And here are cheese. And I said, how many sandwiches can you make? Well, each sandwich has a bread, a cheese, and a bread, right? So I can make one sandwich, and that would get rid of those. And then I could make another sandwich, and that would take those. And now I'm out of bread, so I can't make any more sandwiches. I can only make 2 sandwiches. I have some cheese left over. So that means in this example, the bread was my limiting reactant because I ran out of the bread first and I couldn't make any more of the sandwiches, which were the product. So for a limiting reactant problem, what you're going to need to do is 2 gram-to-gram stoichiometry conversions. The way these problems will be set up is it will give you both amounts of your reactants, and so those are your 2 starting numbers for your 2 stoichiometry conversions. So I'll write both of those down. So for one, I'm going to start with 150 grams of titanium bromide, and for the other, I'm going to start with 150 grams of hydrogen. Okay, so there's the start of my 2 problems. And what I'm going to try to see is how much of one of these products can I make. And it doesn't really matter which one you pick. You could pick the titanium or you could pick the hydrogen bromide, titanium or hydrogen bromide, but oftentimes there might be a second part to a question like this, and if we look down at part B is asking me how many grams of hydrogen bromide can I form. So I want to save myself some time and not have to do this problem twice essentially, and I'm going to pick that product. So this is going to be my endpoint, grams of hydrogen bromide. And then I'm doing my grams A to grams B conversion. So I have to take my unit and move it down for the next one. And same with this side. I'm going to kind of do both of them at once. And if I need grams, that's where I need a molar mass. I need to look at the periodic table and I need to add it up. So for hydrogen gas, H2, it's going to be 2.02 grams. And for the titanium bromide, 127.77 grams. And then the other side of that molar mass fraction always is 1 mole of that thing, because that is how much 1 mole of that thing weighs. All right. Third fraction in the grams to grams conversion is going to be the one where I take my equation and I get my moles from that. So moles, titanium bromide, moles, hydrogen gas, because I'm always bringing my unit down for the next one. And I'm going to look at the equation, and it says for the titanium bromide, that's 2 moles. For the hydrogen gas, that is 1 mole. And then up here, I decided the product I'm going to look at is the hydrogen bromide. So I'm going to put 2 moles hydrogen bromide here, and it's going to be the same here. Okay, now one common mistake with these limiting reactant problems is starting with titanium bromide and then trying to calculate how much hydrogen, or starting with hydrogen and trying to calculate how much titanium bromide. That is not what you want to do. What you want to do is calculate for both starting reactants how much of one of the products over here, the products you can make. Don't calculate one reactant to the other reactant, calculate them both to the same product. So we don't want to say like, oh, how much bread do we need for this cheese, and then how much cheese do we need to this bread. We want to say, how many sandwiches can we make with this? How many sandwiches can we make with that? That's the approach we want to make. We want to look at the product. So, last step is the grams. Always bring my unit down. So mole HBr, 1 mole, and the grams, which I will again get the molar mass by adding it up with the periodic table. And that one weighs 80.91 grams. Okay, so I've got these set up. Now I just need to do the math. So multiply the whole top, multiply the whole bottom, divide the top by the bottom, and so I will get 94.99 grams hydrogen bromide here, and I will get 12,016 grams of hydrogen bromide here. So, with 150 grams of titanium bromide, I could make 94.99 grams, and with 150 grams of hydrogen, I could make 12,016 grams. So now I need to say, well, which one of these is smaller? That one's smaller, right? That one's smaller. So that means that the titanium bromide was my limiting reactant in this problem because it made less. Just like with the sandwiches again, I could make 2 sandwiches with the bread, and I could make 3 sandwiches with the cheese. But really, how many sandwiches can I make? I can really only make 2, because the bread was the limiting reactant. It limited how many sandwiches I could make. So similarly, on this problem, I could make this many grams here with the titanium bromide. I could make this many grams with the hydrogen, but really, I could only make this many grams because I'm going to run out of titanium bromide before I run out of hydrogen. So my limiting reactant is the titanium bromide. And then for part B, how many grams can I form? It's that 94.99 grams, the smaller number. And this last one is a percent yield. So on the last page, we calculated that we should be able to make 94.99 grams of hydrogen bromide. That is our theoretical yield. And then the problem here tells me we actually made 76.5 grams of hydrogen bromide. So for percent yield, I need to take my actual yield, 76.5 grams, divide it by my theoretical yield that was calculated in the problem, 94.99 grams, and then multiply that times 100%. So when I do that, I get an answer of 80.53%. Not too bad. So that is standard 3.3, part 2 of the review.